Okay, so this is chapter 10.4 in your textbook, Translations of Functions. In this unit, we're going to be talking about vertical and horizontal shifts of different kinds of functions. So wait a minute. We know how to do this. We did this with every single function unit that we talked about. So we've talked about transformations of quadratics, exponential, square roots, absolute value. The only difference is today we're only talking about vertical and horizontal translations. We're not talking about our compressions or our shrinking or anything like that. Only vertical and horizontal translations. So vertical translations, let's talk about that one first. We have a function f of x. And if you add or subtract a constant value to it, then it's going to move up and down. Okay, so g of x is our transformed function. F of x is the original. Okay, if you add a constant, you shift up. If you subtract a constant, you shift down. So let's take a look at a couple examples. So our first one is a parabola, and you can see the original is in blue. We have x squared. They took that and they added 2 to it in the red one. So they took the original f of x equals x squared and they added 2 and it made it shift up 2 spaces. Now we have written it differently before. We would write it as g of x equals x squared plus 2. Technically, these are exactly the same thing. It just instead of writing the x squared again, they put f of x in its spot. This one is an exponential function. And you can see that, again, the blue is the original, 2 to the x power. They took that original function and they subtracted 3, which made it shift down 3 spaces. Okay, this is a square root function. Okay, so our original was just the square root of x, our parent function. They added 1, which made it shift up 1 space. Okay, so at this point, go ahead and pause the video, and I would like you to tell me, how does the k, or the constant, affect this graph for f of x and g of x? Okay, so this one was pretty easy. And the first one, they took the f of x function and they added 7 to it. So by adding 7, that's going to make it shift up 7. In the second one, they took the f of x function and they subtracted 9, which made it shift down 9. Okay, let's talk about horizontal translations. So in vertical, we were adding a constant outside of the x. This one, notice how we have our h and it's inside touching the x. So that's how we know it's been a horizontal translation. Okay, so in this case, we have f of x equals the absolute value of x. That's our original, the blue. And g of x is f of x plus 2. So again, another way of writing it, if you expand it, g of x, erase all that, equals the absolute value of x plus 2, inside touching the x. Now, if you remember, the h value is the opposite of what you think it is. Okay, so if we see plus 2 on here, in our mind, we think, okay, we're moving in the positive direction. We're going to go to the right. But in reality, it's moving to the left. So you can notice our graph, the red one, is left 2 spaces from the original. Here is a quadratic, okay? And in this case, we had x squared as our original. They subtracted 1 inside the parentheses with the x. So again, opposite what you think. You're not moving in the negative direction. You're moving 1 in the positive direction. So you're moving 1 right. All right, and then this one is a cube root function. And our original is in blue, the cube root of x. They added 3 on the inside of our parentheses. So that is going to move left 3. Go ahead and pause your video, and I want you to tell me, how does the h value affect these two graphs? Okay, so again, pretty easy. If you are subtracting 8 and it's touching the x, it's moving along the x-axis, it's going to move right 8. Okay, and then for the second one, they're adding 7, so that is going to move left 7. All right, you can also have a combination of translations. You can have more than one thing happening at once. So in this case, if we look at this, I see the +4 inside. So it's inside touching the X. I know it's going to move left or right. So it's the opposite of what I think it is. So instead of moving right 4, it's going to move left 4. All right, and then this -1 is a constant. It's at the end. Sometimes they do put it in the front, but this is our constant. -1 means down 1. And if we look at the graph that I put up a little too early, you can see it went from 0, 0, and you moved left 4 and down 1. Okay. This one here is an exponential function. And I could see here, up touching the X, we added 4 to it. So that makes it move left 4. And the -1 makes it go down 1. Okay, now this one, the last one I looked from the vertex and I saw where the vertex moved. When it comes to exponential functions, you want to look at 0, 1. Because if you remember, all exponential functions start at 0, 1. They don't start at 0, 0 unless they've been transformed. So look at that spot and then see, okay, well, I need to move left 4. So 1, 2, 3, 4, and then down 1. Okay, this one is a square root function. So again, they use the same numbers. So this is going to move it left 4, and this is going to move it down 1. All right, when it comes to these ones, our square root ones are never in the negative quadrant unless it's been transformed. They always start at 0, 0. So look at that point, and we're going to move it left 4 and down 1. Okay. All right, so go ahead and describe these transformations. Pause your video. If you need to, you can graph them, but I think that you guys can figure it out just by looking at the actual equations here. All right, so let's take a look. In this first one, f of x, we have two things happening. This is a quadratic because I see the squared. So the first thing that happened was we have our -2, so that's moving left or right. And we have our +3, our constant at the end that moves it up and down. All right, so -2 is going to make it move right 2, and +3 is going to make it go up 3. Whoops, sorry. Let me go back and show that to you again. I clicked too fast. So like I was saying, we said right 2 and up 3. All right, this one, we have something going on up here with our x, and we have our +3. This one is exactly the same. It's just an exponential function. So touching the x, this is also right 2 and up 3. And then this one here, we have our -2 touching the x and our 3. So all three of these functions, I think they tried to trick us. All three of them are right 2 and up 3. All right, so the classwork for this one is page 432 and to 434. You're going to do problems numbers 3 through 8 and number 11. The exit ticket is page 435, number 10, 9, and 10. Make sure that you're turning those into me so I can record them and give you feedback. In order to get a passing score for fourth quarter, you need to be doing these exit tickets and submitting to me so I can put them in the grade book. Please note, I changed the exit ticket slightly on Schoology because if you look at the textbook pages, it has you sketch a graph. Well, it's really hard to sketch a graph on the computer and then submit it to me. It's possible. If you would like to do that, feel free to sketch a graph and then email it to me. So what I did instead was I made it a drop down where you have to tell me the directions that we're moving. So it might be just a tad bit easier than trying to sketch it on the computer and then submit it electronically. If you have any questions, feel free to email me or you can jump on Blackboard Collaborate during my office hours.